All right, everyone. I have about two past the hour, so I'm going to go ahead and get started. Good morning, good afternoon, depending on where you're located. My name is Ryan Fragapane. I'm one of the two product directors here at AASHTOWare, and one of my responsibilities is the AASHTOWare Safety tool in conjunction with the Strategic Advisory Committee and New Metrics. So I want to thank everyone. I know it's right after the holiday, so everyone's getting back into the swing of things after a nice long weekend. So I really appreciate everyone taking the time today to spend some time with us. I think it's going to be a great webinar on alternative design and tools that have been developed to help the design groups. So I really appreciate everyone's time today. Real quickly, a few housekeeping before we get into it. As you probably saw when you joined, this is being recorded, just so you're aware. It'll be recorded after this webinar is complete. The recording will be made available. So everyone who registered, even if you didn't attend, you'll receive an email with a link to the recording. It'll also be posted to our website so anyone can access that. So feel free to share the recording with anyone who couldn't make this webinar. Additionally, because we are recording, we do have everybody muted. So everybody currently on the line is muted and you will not be able to speak. This way we can just keep a nice clear for our speakers and make sure the recording is able to pick everything up. We will be taking questions though. So there's a question and answer box on the bottom. If you hover your cursor over the bottom of the screen, you will see a Q&A box. I see someone saying there's some feedback. So if you are hearing feedback, let me know. Someone already put that in the question box. So there's a Q&A box. Go ahead and type any questions you have in there. We will answer them as we go, or we'll save some to the end. It'll kind of vary depending on the speaker and what the topic is. If for some reason we get to the end of this session and we don't answer all the questions, still put them in there. We'll send an email out with answers to all the questions at the end as well. And with that, you can also raise your hand. So if you do need to speak or feel like you have to speak, there is a raise hand button. If you raise your hand, I'll be able to unmute you. But we ask to save that just till the very end. Once again, just to make sure we have a very clear recording that we can share with folks after. So the last pitch I'll make is the 2025 User Experience Advisory Committee. Everybody's invited to this meeting. It'll be September 23rd, 24th in Annapolis, Maryland. You can register. I'll put the link in the chat box. Everyone will have the link to the registration site once I'm done speaking here. If this is something you're interested in, if your state licenses, we'll cover 2 people from your agency to travel. So please feel free to reach out if you're interested in attending. But if you're not from a licensing agency or you're from a consultant and you'd be interested in attending, I'll send that registration link out to everybody after this. So with that, Danny, I'll pass it on to you.
Great. Thank you, Ryan. Welcome, everybody. We're very excited about this webinar. So let's jump in and kind of go over what we're going to do today. So here's the agenda. We'll do a little bit of introductions, including this. Then we'll do an overview of alternative design because there will be references to it throughout the presentation. And since this is so new, we want to give some people contextual understanding about what we're talking about and what people are discussing as they're thinking about policy and planning going forward. Then we're going to have Kevin Scopoline from Wisconsin speak to us on how WisDOT is becoming smarter using different comparison tools. He is the state traffic engineer or safety engineer. Then we're going to have Parker Niebauer, who's a civil engineer in GDOT's Office of Design Policy, talk to us about how GDOT wants to use alternative design to broaden the scope and usage of data on design projects. And then our final presenter will be Vaughn Nelson, PE from UDOT. He's over statewide design. He's a statewide design engineer. And he's going to be talking about preparing for the future, how UDOT wants to incorporate data earlier in the design process. So that's our agenda. And then at the end, we'll have time for a Q&A. Once again, the best way for the Q&A is through that chat. If you can send those through the chat when you think of them so you don't forget about them. And then if possible, we'll answer them in line. And if not, we'll answer those during the Q&A. So feel free to use that chat function for all questions. Okay, I'm going to jump in and give you a bit of an overview of alternative design. All right. So this is the product that is helping designers, right? That is made for designers to help them really implement Part C of the HSM. There's a growing list of needs with regard to designers being able to show statistical significance for decisions they make, especially with regard to safety. And so this is going to be a brief overview of what designers are beginning to do and beginning to work with. Now, one thing I do want to point out at the beginning of this is a brand new tool that is being implemented by 6 states right now, 3 of which, and when I say implemented, it's either on their roadmap or they've gone through the user acceptance testing. In the case of Georgia and Utah, their design groups have gone through user acceptance testing, so we'll talk about that. But this is very much initial stages. So you're going to hear a lot from the designers and the presenters about where they want this to fit into their process, because it is new. It's not something that has an established 10-year track record. This is brand new because a tool like this hasn't really existed for designers to be able to do these statistical findings for themselves. And so we'll talk through them. But this is the initial page, and I have a project all set up. And this project includes 2 intersections and 2 segments. So we have Lower Burning Bush, which is down here. We have Burning Bush and Alexander Bridge, Upper Burning Bush, and Burning Bush and Reed's Bridge right here. So this is very much a way for designers to start setting up what the project extents are and what they want to include within the project. This is done by simply clicking Add Segment or Add Intersection, and they can add whatever they want to. I'm not going to go too much into this just to keep it short, but this is the output of that initial setting up. Next, the designer will go in and they'll fill out some information about the project. So this is that very first Lower Burning Bush. They type in the name. Now, this is based on the Highway Safety Manual. And so all of the calculations that are found inside this software come directly from Part C of the Highway Safety Manual. So these are the roadway types that have definitions and have the predictive metrics assigned with our predictive statistical analysis done for each of these. And so for this project, we're just going to be looking at a rural 2-lane road, but this works for multi-lane roads, divided, undivided, urban and suburban arterials, freeway segments, ramp segments, and collectors and distributors. So that just gives you your roadway type. You select that. Now, all of the AADTs are already in the software, so the designer doesn't have to worry about getting that. It just flows right into the software. The next thing they're going to do is they're going to go and basically say, if I were to look at the roadway right now, this is what it looks like. So right now, this has 10-foot lane widths, 6-foot shoulders that are turf, and you can see the horizontal curvature, super elevation, gradation, driveway density, as well as center rumble strips, and lighting is another one that we'll touch on. So this first piece is just, if we were to go and look at this right now, what does the roadway look like? And so I have this piece in here, just a tip of the hat. A lot of this is changing with Highway Safety Manual too. And so we're all stubbed in ready for when that starts going live. And it'll include more bike and pedestrian features, but they're not in there yet for this. Now, right now, you can see in this top, we're looking at 5 years of data. So over the last 5 years, this shows all of the crashes that have occurred. And the mile extents 1.57 to 3.16 on Lower Burning Bush. So that all just flows directly in. So the designer has an idea of what kind of crashes are happening. If they want to, they're able to open this up in Crash Query and dig even more into crash narratives, types of crashes, maneuvers, all of those types of things. But suffice it, for the statistical analysis, this gives us what we need. Same thing for intersections as for segments, except for there's a couple of AADTs, because you have your major AADT and your minor AADT. And then you also have your intersection type. So multiple types of intersections. And then in the roadway details, you'll see that it's obviously different because it's an intersection. You have skews, left turn approaches, right turn approaches, those kind of things. So that's just configuring what it looks like right now. So we have all of those done. Now I'm going to go into the no build section. What this is going to do is it's going to say, do you want to include, as you're analyzing it, do you want to include AADT growth? And we're going to say, yes, we do. And we want our project to be considered on a 10-year basis. So what we want to do is go out the 10 years. If we were to do this now in 10 years, what is our benefit for all 10 years, including that 3% growth rate? Now, if you have an ongoing project there already and you want to include that cost, you can do it here. Last thing is the summary. And this is going to start giving you some of those empirical Bayes numbers. And this is going to say, based on the history of crashes, as well as your SPF associated with this, and the CMFs, which I didn't really touch on, but when you input the lane width, so right here, you're going to see the adjustment factor, or CMF, is 1.17, starting to let the designer know, hey, this might be something you want to look at because this is higher than the base condition. And so what we see in the summary is all of those, the combination of history, SPF, and CMF, and 10 years. And this is what's predicting or expecting for the next 10 years at all 4 of those locations, anywhere from 30 crashes to 108 crashes. So this is all base conditions, and we're done. Or if we were to look at the road right now, if we didn't do anything, this is what we'd expect over the next 10 years. So one of the big reasons that designers are looking to use this tool is because designers are being asked to do design standards, meet design standards, and understand when design exceptions make sense and when they don't make sense. So if I were to come in here and say, I want to move this from a 10-foot lane width to a 12-foot lane width, I simply do it by changing the dropdown, go to 12 feet, it updates it, and we can see that we are expecting the crashes to go down based on the adjustment factor updating. As well as if we were to pave these shoulders, it would also go down ever so slightly. So we're just going to make those 2 changes on the segments. We're not going to do anything to the intersections, but we are going to make those changes here for the segments. And then I'm going to go in and I'm going to put a total construction cost of about $750,000. It gives me a total benefit, and it gives me a benefit cost ratio. It also starts telling me where I should start seeing the crashes reduced over the 10 years. Now, I'm not going to go into it just for sake of time, but we did the same thing for lighting as well. All we did is we went down and said, let's just add lighting to all the segments, all of the intersections, and we added a cost of $250,000. We have a benefit over the next 10 years, as well as the benefit cost ratio. We then did a combination of the 2, and for the third one, we just did lane widths and lighting. Now, ultimately, what this gets us to is a comparison report. Now, this report, we say, shouldn't win any wars or any arguments. However, this should bring data. This should bring insight into, as we're considering a project at this location, what do we potentially see the possibilities of? Now, if we're just looking to get if we don't have a lot of money and we want to get the best benefit cost ratio, then just putting lighting in is probably going to be our best bet, because we're going to get about a 13% or a 13 multiplier on our cost, as we're going to get about $3.34 million for that lighting proposal. However, if we are looking to decrease fatalities, decrease crashes, and just generally help out with safety, then doing both the lane widths and the lighting really is giving us the biggest benefit overall, and it still is providing us a good benefit cost ratio. And you start seeing these things compared to each other with regard to benefit, project, net benefit, and benefit cost ratio. So that's very fast, and I recognize that's very fast. Obviously, if you want to see this in greater detail, we can have some conversations after this, but I did want to give you a little bit of context around what the alternative design tool is that the presenters are going to be discussing, especially as the designers are thinking about concept level designs and thinking about it differently. this is the tool that they've been working with and started to design and develop with us. So with that, I'll stop presenting and I will bring Kevin on. And Kevin, I'll let you take it away from there.
All right. Hopefully everybody is seeing my screen now
Yep, looks
and can
good.
hear me. Perfect. Thanks, Danny, for the introduction. Again, my name's Kevin Scopeline. I work at Wisconsin DOT as one of our traffic safety engineers for the state. The other one is Dan Brugman, and I might have Dan help me answer some questions along the way. Or if you've seen any of our previous presentations, Dan and I kind of trade off. With that, I want to talk about a little bit of what we are structured like at Wisconsin. So we have a central office that Dan and I are a part of. In our central office, we're responsible for a lot of our policy development, looking over different projects, doing some reviews, doing our training, working on implementing tools, all that at a high level to then roll out to our 5 different regions. Each of our regions have at least one safety engineer, and they're the ones that are responsible for doing the network screening, safety analysis, going through, doing actual project submittals, looking for locations to improve through things like the Highway Safety Improvement Program. So I know Danny talked a lot about the tools and specifically alternative design being used by designers. Um, in Wisconsin, we have it structured a little bit different where our safety engineers are the ones doing most of this work. The reports and everything that get generated then can be and are reviewed by our designers. So still having that easy to read, knowing what's going on is very valuable still, even though it's our safety engineers doing the work, not the designers. To give a little bit more of a background, and like Danny, I'm going to go through this very quickly. For us, in terms of implementing the HSM or Highway Safety Manual, for a while we weren't doing anything with it when it first published in 2010. And then in 2018, the big turning point for us was getting our safety certification process, which I will probably refer to here on out as the SCP, getting that published, which really gave us the ability to say, all right, all of our improvement projects, we're going to have you do a more in-depth safety analysis. And that's kind of our policy that we've been updating and continuously making improvements along the way after we published it in 2018. And like Danny mentioned too, we're looking to continue to work on that. Excited for the HSM2 to come out, seeing how we might be able to incorporate vulnerable road users more into our policy, and then make sure that our 2 different processes, the SCP and the Highway Safety Improvement Program, they align and are more linked together. So again, very high level overview of where we were, what we're doing now, and kind of where we want to go for our safety analysis. Because of that, and as we're starting to transition, we have a lot of in-house tools that were built to do a lot of what AASHTOWare can do for us. So the arrow pointing down that says smarter on the side, smarter is in quotes. It is smarter, but I'd also say that it's more data intensive, right? Crash query is usually just looking at what crashes are out there and doing a hotspot analysis. So as you work your way down, you're adding in more and more layers of data to hopefully get a better, more robust, analysis result coming out of it. So walking through each one of these applications. The first one, Wisconsin has up and running. Again, it's pretty easy to use. Being able to see a map with all of the crashes on there is very, very helpful. This related tool that we kind of have right now, we have 2 of them through our WisTrans portal data and community maps. Both tools are useful, and we view Crash Query as just being another one that hopefully we'll be able to open up to a lot more users, get the data into more people's hands to visualize, be able to say, oh, we have some concerns here. What should we do? What can we look at? And start pulling some of that information together very, very quickly, being able to go through it and apply some easy filters. Again, we already have this on board, which is great. And so the next thing that we're kind of working towards is getting network screening up and running. This for us is really going to be the basis of what our safety engineers do, going through being able to identify, I'm showing the intersections one right now, but both intersections and segments, knowing where we have locations. We call them safety sites of promise, but essentially all it is saying, hey, take an extra look at this location. Something's going on here that we want to make sure that we're examining a little bit more closely. So that way we're not letting those locations kind of slip through the cracks, and we're addressing our safety issues as our projects move along, through the different corridors with the improvement program. We're hoping to roll both the intersections and the segments piece out this summer, maybe into the fall. So that's what we're really working on right now, is getting this up and running, making sure that we're understanding it, that it's doing everything that we need to from a screening perspective, and then getting our safety engineers and other users trained on how to best use this. And then the next piece is the one that this webinar is based on. So I'm going to talk a little bit more about this component. Right now, Wisconsin doesn't have this up and running. It is our next step after network screening. We've started looking into it, and primarily we view it as a replacement for IHSDM, so that interactive highway safety design model that was created by FHWA, has a sunset date, so we know that it is not going to be updated anymore, and eventually support for it is going to go away. So we wanted to find a replacement for that, to be able to do the HSM methodology, more advanced, alternatives analysis. So our goal is to make sure that everything in AASHTOWare Safety Numeric powered, right, that does everything that we want IHSDM to do. And so far in all of our testing, we're very happy with it. As Danny showed, they're also ready and getting ready for HSM2. So when that gets released, we'll be able to incorporate that in as well. So these are our next big steps of what we really want to move towards. And so we're going to do some testing, both with historic projects to see how those would have compared, and then working with a few of our specific safety engineers and regions to go through the process of figuring out, all right, what exactly do we want reported? How do we want things looking? And then being able to incorporate that into our policy. I'll briefly mention dashboards. We have a few up and running. They're very, very nice to summarize data, but not necessarily a main focus for this webinar. So I'm going to move on. I mentioned a lot about kind of where we're at with implementing AASHTOWare Safety. And so we're going through it right now. It's been a very good learning process. The training that we're getting is crucial. And so that next step of making sure that we're getting network screening rolled out smoothly and then into alternative analysis, so far it's been very, very good for us, a great experience, and we want to continue along that path. So hopefully, when these webinars, maybe next year, we'll be able to come back and say, hey, we were able to implement this. This is how we're utilizing it. This is what we were able to see. We're just not quite there yet. And so, like I said, we're really kind of looking to consolidate a lot of the tools that we have already built over the years into, hey, this is AASHTOWare. Let's use this because they can replace or do everything that our existing tools do, and then some. So we're really in that transition phase, looking to validate all of our results and then seeing what new things we can add, and what new capabilities AASHTOWare gives us. And Danny already mentioned one of the great benefits of a lot of the data that we would need for IHSDM gets pulled in already. Having everything in one platform, one location, means that that data gets integrated and utilized, and is just a lot easier for the folks doing the analysis rather than saying, okay, I need to go to this spreadsheet and this PDF and then pull it into here. And oh, I need to go back to look for this new piece of information. Having it all in one place, I think it's going to really, really simplify everything. And then seeing the immediate impact of those design adjustments is going to be, I think, very important too. So again, going through really quickly just because I want to get a lot of information out to folks. Please feel free to give questions in the chat, or if you want to reach out to us, have a conversation. Dan and I are happy to talk about our processes, what we've seen, some of the issues that we see, and how we're trying to move forward and address those.
Yeah. Thank you so much, Kevin. Two things really quick about Kevin. I just want to point out, Kevin and the team, Dan in Wisconsin, have been some of the most knowledgeable with regard to their implementation of the IHSDM and how they are using predictive metrics for the last, feels like probably a decade or close, maybe half a decade, with regard to in their policies and processes. And they were ahead of the curve in a lot of ways. So really appreciate that. The other thing that I appreciate about Dan and Kevin both is they're very open about the overcoming obstacles. Like, the obstacles do exist. Whenever I talk to them, it's never a, yep, and it was done. It was like, this is what we had to do. And as we've talked about it with other state partners, it's been empowering for them as well, because they're like, oh, good, other people face these challenges too. It's not just me. So I really always appreciate Dan being willing to share that kind of stuff with us, or and Kevin being willing to share that kind of stuff with us. So thanks, Kevin. Okay. Our next speaker will be Parker from GDOT, and he's going to come from the Office of Design Policy. So Parker, I'll let you share your screen.
Okay, thank you. All right, can you see it?
Yep, we can see it. Thanks, Parker.
Awesome, thank you, Danny. All right, so my name is Parker Niebauer. I've been with GDOT for about 11 years. I spent 5 years in our district design office, 4 years in our district traffic operations office, and the last year and a half in our design policy and support office. So I've got the org chart for our office pulled up, just kind of showcasing where I fit into everything. Our office does a lot, but I think the most relevant to alternative design is going to be Hoke's team. And Hoke's team is split between design policy and roadside standards and safety. So on the policy side, Hoke's team is reviewing design exceptions and design variances. They're also writing and revising our design policy manual. And then on the standards and roadside safety side, there's me and Jose, and we primarily are reviewing shop drawings. We're kind of the library for standard drawings, especially roadside safety standard drawings. So guardrail, concrete barrier, cable barrier, that kind of stuff. And then our office is kind of, the SME around roadside safety, the roadside design guide, all that kind of stuff. I don't do the design policy side as much. I have been able to sit on some design exceptions and variance committees and see kind of that side of the process, but I am primarily on the standard drawings and roadside safety. I will also note that, I am kind of down here low on the totem pole. I'm not a policymaker or anything like that, so take what I say about GDOT's expectations with just a grain of salt. So today, Danny asked me to talk about challenges that face GDOT designers when considering safety in concept level designs. How will designers benefit from having alternative design as they begin their designs? And where do I see alternative design fitting into GDOT's process? I think if you look at the design spectrum, you have dimensional design, which is you're getting your design values from tables or equations like the Green Book. And then you have performance-based design, where you're looking at design values from project needs, objective statements, and performance goals. And currently, I think GDOT is kind of on the left side of this graphic, where we lean more towards dimensional design. So especially with our traditional projects. So when you get a traditional project, the goal kind of is anything that the project touches, you want to bring it up to standard. And then where that's not feasible, we do encourage through our practical design guide designers to achieve flexibility in their design through the use of design variances and exceptions where appropriate. All right. So I think an example of a way that we do this well is with our GDOT intersection control evaluation tool. I think a lot of the states have something very similar to this. We select some feasible alternatives for our intersection and then estimate the project cost of each alternative. Then we look at traffic delay for each alternative and crash reduction factors for each alternative. In our ICE tool, the CMFs are kind of built into this already. So all the designer has to do is, select existing as two-way stop control or all-way stop control, and then select the alternative is roundabout or signal or whatever. And then these CMFs or CRFs automatically populate. All right. And then we rank or score these alternatives based on the factors in the previous slides, along with some stuff like stakeholder input and environmental impacts to get our preferred alternative for the intersection. So that works really well for us for intersections, but what about non-intersection safety performance? So shoulder width, lane width, cross slope and curve radius, etc. We don't really have any automated safety analysis feature for these. We don't have any one-stop shop or dashboard for this. We're reliant on the Highway Safety Manual, or the HSM. All right. So how can designers benefit from having alternative design as they begin their designs? So a couple of things that jump out to me are standardized inputs for these HSM variables. All the designers are putting these in the same way, the same shape, the same form. So everyone's putting them in feet and not miles. You're not worried about, what does this one mean? Are we doing this one in quite the same way? It's a little bit of plug and chug. So you don't have to be as familiar with the HSM to use this tool. You have standardized output for reviewers when it comes across the reviewer's desk. Everyone's looking at the same thing. They can know earlier what they want to make comments on, what they want to send it back for, if they want a different alternative looked at. It pairs well and syncs with AASHTOWare's crash query, so you're not having to go to a separate crash dashboard or database to collect your crash data to input into this program. It's already grabbed internally in the program. It provides you benefit cost ratios. It lets you do multiple analyses and it lets you tweak those analyses. It also lets the reviewer tweak the analyses if that's something that your team has set up, something that you want your reviewer to be able to do. They can make a copy of it and tweak something or add their own analysis real quick without having to send it back through a project manager and however many people to get back to the designer. And I think ultimately it's going to reduce your analysis time and let you kind of start this a bit earlier in your process. So Danny already showed some of this stuff, but I just wanted to give it some context here in mind. So what we just saw in the previous slide, we're looking at on the left side of this slide, you can see how those different alternatives result in different expected crash frequencies. And on the right side, you can see how your different alternatives have different either just benefits or different benefit costs. And here's a summary. It's a different data set than the previous slide. This is not necessarily real world costs and benefits, but this is for a proposal 3. And then you can see on here that we've made changes to the median width in segment 6 or the lighting in segment 11. And then we can see how each of these individual changes can affect our CMF or CRF. And then we can also look at what's the benefit cost for this specific alternative. So where do I envision this fitting into GDOT's design process? I think it's going to be really helpful at concept. In our concept reports, I have an excerpt here of what's from our template, and we look at, kind of tabulate a lot of the features that are important to us at GDOT and list what's the existing feature, what does the policy require, and then what are we proposing to put out there once it's constructed. And if our proposal is matching the policy, great. But if our proposal is less than the policy, all right, what do we do? So obviously we're going to document, and I think this tool is going to help us document and make those decisions earlier. So if we know that, maybe we've got some environmental impacts that we're trying to avoid, or we're constrained on a right of way, we can make the decisions earlier in concept and get the ball rolling on these design exceptions and variances earlier to say, all right, well, if I can't get the 10-foot shoulder that I need, what's going to be the impact of using an 8-foot shoulder? What effects are those going to have? This is also from our concept report template. We're just looking at our FHWA controlling criteria and determining, early in the concept stage, do we anticipate this to require a design exception or design variance? Again, like I said, we want to get this started, the ball rolling on those exceptions variances as early in the process as possible. So if we have the data to make those decisions as early as possible, it just helps the process go a lot smoother. Same thing for our GDOT standard criteria, which are things that FHWA hasn't identified as a controlling criteria, but that GDOT sees as important enough that we want it documented with a design exception or a design variance. And this slide shows a excerpt of our design exception or our design variance template. Probably the section of this report that we want to look at is the alternatives considered and the risk assessment. So our template advises our designers to use the Highway Safety Manual and the HSM spreadsheets to predict the impact of proposed alternatives on safety. If applicable, not everything has a documented CMF or a CRF. And then this also advises designers to list any additional design exceptions or variances that overlap in the proposed area and properly address their corresponding risk. So this last section might be a little bit different because we're looking at design variants and exceptions that overlap. What's the risk of compounding those in that section that overlaps? But this tool kind of lets us apply that to the whole project and see, once we start stacking reduced shoulder width on top of reduced lane width on top of, non-standard horizontal radii, what is this doing to our project, and are we comfortable accepting that risk? And just an example, I've talked a little bit about the design process and where this could fit in, but I think it has benefits outside of just the design process, or even for projects that don't go through our typical standard design process. So an example that comes to mind would be our traffic operations team, which might function similarly to some other DOT's safety team. They get a lot of complaints about, hey, we've seen some accidents at this intersection. Can you fix this? And their response might be more performance-based driven than dimensionally design driven. They're not going to say, yeah, we're going to put the standard in here. They might just say, hey, what can we do to make this better? So if they need to fit in a turn lane or something, but they don't have the right of way to get the full shoulder or a full turn lane width, they can use this tool to kind of compare some alternatives and say, well, what does it look like if we do, if we take away some shoulder? Or what does it look like if we do a combination of playing with our lane width and our shoulder width, and what is that going to do to our benefit cost ratio? I think that's a huge help for our traffic operations group, which has, a program fund, and they've got to decide where can we put this. They're looking at the most bang for their buck. I think at one point they were using like a benefit cost ratio of 6-to-1 as their threshold. So being able to say, this only has a benefit cost ratio of 3-to-1, we'll put it on, a watch list, but we're going to throw our money at something that we can get a little bit more bang for our buck. And that's it for me. Let me know if you guys have any questions.
Parker, it's been a blast getting to know the whole GDOT team during their UAT experience. It's given a lot of feedback, a lot of good feedback, and Parker has been one of the people at the forefront of that, so I really appreciate it. We have been receiving some questions. We're going to please keep those coming in. We'll get to them after Vaughn goes. So please, as you have questions, feel free to send them in. But we are going to turn it over to Vaughn, let him give us a presentation about what he's doing there in UDOT. So Vaughn, when you're ready.
Thank you. I'm impressed with Wisconsin and Georgia and their how advanced they are compared to UDOT with their forms and their documenting of safety. So good job. I may have to contact you and see how you're progressing on that and how it can help us. Is everybody seeing my screen okay?
Yep, looks great.
Okay. So I am Vaughn Nelson. I'm the statewide design engineer for UDOT. I manage the design standards and help with tools and processes to get projects out to construction. Here at UDOT, we are adopting the safe systems approach, where we want to improve our overall transportation system. And I see design as having a large role in this process. And that's where we make a lot of the good decisions that affect our transportation system. But in order to do that, we need better data to justify our decisions. Instead of just pulling it out of a table, we can answer the why of what our decisions are on each project. We also need shorter time to come up with those decisions. Many times we don't have funding available to hire a consultant. We're very consultant heavy in Utah. We don't have, it's like 95 or mid 90s percentage wise of the projects we send out to consultants. So we don't have the resources or the manpower to do a lot of projects in-house, but we have to make decisions on what the projects are going to include well before funding is involved. So we need something that's simple to use and that can provide that information on it in our time frame. Usually that is that concept. We develop all of our concepts in-house and a lot of times have to make assumptions based off of very limited data. And we want to be able to better our process and better the data that we receive so we can make those decisions quicker and better. A tool we are looking at to do this is performance-based practical design. Another way of looking at this is just to build the best transportation system we can afford. I was talking to someone last week on the practical design side of this, and they just kind of giggled and says, well, what is practical? And the answer is it's different for everybody. And so tools like the alternative design software help us in each DOT to determine what is our practical. For someone who makes 30 grand a year, what's practical to them is very different than someone who makes $500,000 a year. And so we can't ignore our finances when we're making decisions. And that's why we have to include that in our performance-based analysis. I've had the opportunity over the last few years to serve on the AASHTO Technical Committee for Geometric Design, and we've been tasked with providing flexibility in the next version of the Green Book, Green Book 8. Part of that is to use performance-based design that is context-driven, so that our individual project teams and individual transportation agencies can make better decisions and provide a better system, and not be forced into following a table that may not fit into whatever situation they are working with. This little chart here comes out of the NCHRP research project 839. It just shows the difference between, providing a substantive safety versus a nominal safety out of a table, where we can better fit those needs to the project. In order to make those decisions, we have to have the data, and it has to be data that can be presented in an easy way for our decision makers to make those decisions. And oftentimes those people making those decisions are not safety engineers. So when it comes to safety, we needed a tool that was easy for designers to use, and that we could make decisions based off of the actual data of our roadways early enough without making too many assumptions or incorrect decisions. About a year ago, Danny came to me and asked what I thought of this software, and I asked him to make it specific for designers, that they could interface with it at their level without being experts of the HSM. And I'm sure he already had that figured out, but I like to tell everybody that he customized the software just for me and Utah. So, if that's not the truth, just don't tell me or my management. We'll just run in our ignorance on that. But we're using this software just for this, to gather that data to be able to make better decisions. This design software is integrated right with our traffic numbers to provide that quick access and easy analysis of the numbers on our roadways. And we don't have to worry about complicated spreadsheets. We've been dependent on consultants for our HSM analyses. Our designers don't have any real knowledge of the HSM. They haven't had the ability to research that. And our traffic and safety group is so small that they haven't been able to do that internally as well. We've relied heavily on consultants. And this software provides that opportunity for them to do comparison analysis of different alternatives that we can make better decisions on without relying on consultants or needing project funding before we set the scope of a concept. Some feedback that we've received from our designers: we've been using this for just a few months. We've been hitting it pretty hard with our designers to test it out on either projects that are currently running or recent projects that they've just advertised, that they could try it out and see if they would reach the same conclusions using the software. A lot of feedback comes from our 3R type projects, our rehabilitation and resurfacing projects. This software has been able to provide the justification documentation for our design exceptions. And that doesn't fit on every project, but for our 3R, it has done a good job at providing some data to justify our decision. It has greatly reduced our dependency on consultants. And we see this as a great benefit going forward, where we can do these analyses in concept before we have money to hire a consultant, and get that data sooner and be able to make better decisions. A lot of our designers have been using this in review meetings when someone has a alternative or a suggestion that they would like to consider, the interface of this software is such that they can pull it up right in the meeting and either quickly eliminate the option or decide on further analysis. That's been very useful to them. The frustrating part is their lack of understanding of what is included in the HSM. Very quickly, they were frustrated with the inability to compare lane and shoulder widths on urban arterials. And that's just because of their lack of understanding of what's in the HSM. But that is not a alternative design software problem, but that also helped them understand, what we can do with this, and that it is not a one size fits all tool. It has its purpose, but it doesn't fix everything. We need to know when it's appropriate and when it's not. Another desire from the designers, is to customize the software with UDOT specific CFMs and to include our roadway geometric design standards, where we have something that's a little more stringent than the Green Book. Those are not included in this, so we have to understand that when we're making our decisions. We've asked Danny and his team to come up with a best practices document. This is a set of instructions that will help our designers quickly understand when this tool should be used and probably when it's not appropriate. I think the biggest thing I've heard from our designers is the time that they're able to get this information. A couple designers have gone back on projects where they've had to go through the full process for a design exception. Project had to hire consultants, and it was days of coordination, sharing project information, making sure that they communicated the needs of the project and what they were seeking in that design exception. They were able to get the same conclusion in minutes that took days of coordination with a consultant. And I see that as a huge benefit for the state and for our design teams, so that we can make decisions earlier in the process, even if we have to do more analysis and hire a consultant that fully understands the HSM later on in the project. At least we can make better decisions up front before we seek funding and before we set a schedule. We can benefit the public better. Going forward, our desire is to integrate this more into our concept development and into our 3R project delivery. We are converting all of our 3R projects into a performance-based decision-making process where we do not have minimum design standards. So we would be full performance-based on those projects. And this will be a great tool to help our project teams make better decisions and understand where we should apply our money. It's been very difficult in the past and currently to use what our pavement group calls pavement money to make it a safety improvement on a roadway. With this software, we can demonstrate the benefit to the public and determine when a safety benefit is more value to the traveling public than, say, a lane mile of pavement. These analyses will take out the opinion and emotion out of decisions so that we can compare data and point to the data when we make a decision and need to justify or defend that decision. Like I say, we're kind of just starting this process. We're developing the tools that Georgia and Wisconsin have for documenting our design decisions when it comes to safety. And hopefully we can use this software to help us in that process. But I've been very impressed with it, and I'm hopeful that it will be a great tool for us to use.
Awesome. Thanks, Vaughn. Thanks again to everybody to Kevin, Parker, and Vaughn for taking the time to talk to us today. I know there were a couple of questions that came up, and I don't know, probably Vaughn or Parker, since you've had a little bit more experience with the tool, like where have the costs come from? Where do designers get their costs that they put into this application?
So our designers will do a concept level estimate, usually just using some spreadsheets that we already have generated. They'll put it together as if they were putting a engineering bid together for that particular item and put that in as the cost.
Sweet. Yeah, so it is all coming from UDOT and the designers. There is potential, the idea of if we can standardize costs and those kind of things and have it put in there for the designers in the future, potentially being able to do it. But right now, it's the designers doing everything manually and putting it in there. Thank you. I know we're at time. We have some more questions. We'll reach out to you on some of those. But once again, thanks everybody. And then those of you who are AASHTOWare Safety, just a reminder, tomorrow night is the Q2 release. And so Thursday when you wake up, you'll have some new toys to play with, some new updates, and we're excited about that. So keep an eye out for that release. So thanks, Ryan.
Thank you, Danny, and I appreciate it. Tomorrow, you should also receive an email with the recording to this webinar, so that'll be available to all of you. I know there's a few questions left. We will get those answered and sent over to you. If you think of any questions in the meantime, I put my email address in the chat. Feel free to shoot me an email. With that, I appreciate the time. Have a great rest of your week, everybody. Thank you. Bye.